Hello, everybody. We are going to talk about probability mass functions in this video. So we already talked about random variables, and let's just remember a random variable takes an outcome in our sample space and maps that to a real number. Okay. So what we're going to be talking about here is another type of thing called a probability mass function. So a probability mass function sends a value of a random variable to the probability of that event occurring. Okay, so for instance, we could look at, say, if we have some sample space, right? A sample space S, and we have X is a random variable, we could talk about the probability mass function. Let's see, probability mass function, we're usually going to call that little f. So little f of 5, that would be the probability that that random variable is equal to 5. So this is our notation that we're going to use. All right, let's go to a pretty familiar example, which is flipping a fair coin twice. And what we're going to do here is our random variable x is going to be the number of times that heads comes up. Okay. We want to write out the sample space. This is something I would encourage you to pause and then write out the sample space. So go ahead and press pause and do this yourself. Okay. We know that the sample space, right, there's two coin flips, and each one can be heads or tails, 2 possibilities, so we should get 4 things in there. And I'm going to list those out: heads, 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 tails, tails, heads, tails, tails. There is our sample space. And now what we want to do in the second part of this example is write out the output for each outcome here. Okay, and remember, x is the number of times we get heads. So if our outcome, if we flip heads and heads, well, how many heads did we get? We got 2. Okay. So what's going to happen if we do tails and then heads? How many heads do we have here? 1. What is going to happen if we do heads and then tails? Well, we also just got heads a single time. And what is going to happen if we flip tails twice? Well, we didn't get heads at all, so our random variable there would be 0. Okay. So now we want to write out the whole probability mass function for this. Okay, so we're going to need these outcomes and what the random variable is for them. And let's remember that our notation here is we're going to use Q, f of Q. And basically, right, the only probabilities that aren't going to be 0 are we can get 0, we can get 1, and we can get 2. Okay, so let's start with the highest. F of 2, notation tells us that's the probability that our random variable is 2. And that happened, we had 1, 2, 3, 4 outcomes. We got a 2 out of one of those outcomes. So it's 1 out of 4. And that's from heads, heads. And then what about f of 1? That's the probability that x is equal to 1. And we got a 1 out of this outcome and this outcome. So that was 2 out of the 4 outcomes. We can write that as 1/2. And that came from tails, heads, and heads, tails. And then what about f of 0, that's the probability that x is equal to 0, and the only outcome that gave us 0 was tails, tails, and that is 1 out of the 4 outcomes. tails, tails. And we just want to make a note here, right? Technically, this function is defined on all real numbers. Okay, so we can input any real number into that. So we want to have this additional condition that f of q, which remember is the probability that x equals q. Well, if we plug in anything besides 0, 1, and 2, it's going to be 0. Okay. Equals 0 if q is not 0, 1, or 2. So I'm using a little bit of fancy notation here. Q is not in the set 0, 1, or 2, but really we just want to note, right, f of q is 0 except for these three that we specified. All right, let's do one more example where we talk about probability mass function. Okay, so let's think about this example here. All right, we roll 2 fair 6-sided dice. That's an example that we're very familiar with. And here our random variable x is something that we haven't really talked about. It's the number on the first die minus the number on the second die. So let's think about what values x can take. And if you don't really know where to start, we can just pick one possible thing we can roll, right? So maybe I roll 4 and 5, and then we can see, right, what would the random variable be for that outcome? Well, it would be first die minus second die, which is -1. Okay, and let's pick another outcome, say 6 and then 6. First die minus second die is 0. Okay, so let's think about what other numbers can we get? So we get 0 when they're the same number. We can get -1. Let's see, we could also get +1. Okay. We could get -2 and +2. So let's say 4 and 2. That is a roll that we could do. The outcome would be 4 minus 2, which is +2. We could also get that same set of numbers, but the other way around, where the first die is 2, first die minus second die is -2. And so maybe pause and think to yourself about what types of outcomes we could get. Okay. All right. So we can get 0, we can get -1 and 1. We can get -2 and 2. We can get -3 and 3. We can get -4 and 4. And we can get -5 and 5. And those are going to be all of the outcomes that we can get for x. Okay? Because basically the difference can be 0, depending on order. It can be positive or negative. And then the largest that difference could be, right, the smallest dice you can get is 1. The largest roll you can get is 6. So 1 minus 6 is -5. So the largest that you're going to be able to get is sort of -5 or +5. Okay, great. So that's the possible outcomes for this one. So there's 2, 4, 6, 8, 10, 11 possible outcomes. And let's do an example. Let's think about the probability that the probability that x is equal to -2. So we want to find all outcomes where first die minus second die is equal to -2. Okay, so first die minus second die. So that would be, right, 2, 4 would be 1. Let's see. If the first die is 1, the second would be 3. If the first die is 2, the second would be 4. If the first die is 3, the second die could be 5. If the first die is 4, the second die could be 6. And those are going to be all the ones that have a difference of 2 where the smaller number is first, right? If we go up to 5, well, if the difference is 2, that would have to be 7, but we can't roll a 7. Okay, and if we flip the order around, say 6 and then 4, well, that would give us a positive 2 instead of a negative 2, and that's not what we want. Okay, so probability that x is equal to negative 2, there's 4 outcomes that give us that value. 4 out of, we never talked about what the size of the sample space is. Size of the sample space, we're rolling 2 dice. Each one has 6 possibilities, 36 possible outcomes. So 4 out of 36. Okay, and we should note that another way we could write this probability that x is negative 2 is in terms of the probability mass function f of negative 2. And that is what we are going to do on the next one. Okay, and just to note, if you don't want to simplify this, that's fine. In the next type of probability function we're going to do, cumulative distribution functions, it's easier, I think, if you don't simplify. Okay, so let's write out the probability mass function for this. Okay. All right, so we can kind of do this in whatever order we want, and let's remember, right, we could have 0, negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, negative 5, 5, and that's everything that x could take. So I'm going to start with 0. That's the probability that x is equal to 0. Okay, and remember, x is first die minus second die. So when is that difference going to be 0? I'll pretend that we're in class and all of you said, when the 2 dice are the same. Okay, so the outcomes there would be whenever the 2 dice are the same, and the question is, how many of those outcomes are there? And there are 6. So 6 out of 36 possibilities. Okay, now let's think about positive 1, f of 1, the probability that x is equal to 1. So this is going to be, right, first die minus second die. So first die needs to be 1 bigger than the second die. So first die can't be 1 because then that would have to be 0. That's not going to work. Okay, so first die could be 2 and then 1. First die could be 3 and then that one would be 2. First die could be 4, second one would be 3. First die would be 5, second one would be 4, because we're going for a difference of 1 here. And first die, the biggest that first die could be would be 6, and the second one would have to be 5. Okay, if you're having trouble listing stuff out, I find it helpful to sort of pick one, like pick the first die, and think about what options could that be. And I'm thinking about, well, the first die could be 1 through 6, but 1 didn't work, so we saw what happened with 2, 3, 4, 5, and 6, and that's all the possible outcomes. So here, it was 5 possibilities out of 36. Okay? Now let's think about f of negative 1, the probability that x is equal to negative 1. So first die minus second die. So this one, the second die needs to be 1 bigger. So let's think about first die first. If it's 1, second die has to be 2. If our first die is 2, second die has to be 3. If our first die is 3, second die has to be 4. First die is 4, second one would have to be 5. First one is 5, second one would have to be 6. And that's as high as we can go, right? The next option would be first die is 6, but we can't have a 7. So again, we're going to get 5 possibilities out of 36. All right, and we're just going to write all of these out. You can probably already tell it's kind of tedious, sort of tedious. Okay, we did 1 and -1, so let's do 2 and -2. Okay, so the difference is 2. We want the first die to be 2 bigger. So the first die can't be 1 because that's not 2 bigger than anything. Same with 2, but it could be 3. It could be 4. It could be 5. And it could be 6. So that's 4 different possibilities. 4 out of 36. And you might be able to see this sort of correspondence between the positive and the negative, right? So the ones that gave you +1, flip the order on all of those, and that's the ones that give you -1. So the ones that give you +2, flip the order on all of those, and that's going to give you the difference of -2, right? 1 minus 3 is -2, 2, 4, 3, 5, and 4, 6. So again, we have 4 out of 36. All right. Let's think about 3. Okay, so if that difference is 3, it's first die minus second die, so we need the first die to be 3 bigger. 1 is not going to work for the first die. 2 won't work. 3 won't work because that's 3 bigger than 0, but we could have it be 4 and 1, and then we could go up from there. So 5, that's going to be 2. 6, it would have to be 3. And that's as high as that first die can go. That's 3 options out of 36. And now if we think about, got away from me there. If we think about -3, probability that x is -3, well, that's going to be what happens when you flip all of those around. That's where the second die is 3 bigger. That's 3 out of 36. All right. You guys, we're almost done. We're more than halfway done with this example. Okay. And let's think about 4, the probability that x is equal to 4. So that's the first die is 4 bigger. So it can't be 1, it can't be 2, it can't be 3, it can't be 4, because those are sort of too small. But if it's 5, 4 less than that is 1, and that's a roll we can do. If it's 6, 4 less than that is 2, and that's a roll we can do. And that's going to be the only possibilities, right? Because we considered every possibility for the first die. So that's 2 out of 36. And if we think about -4, okay, flip those around. That's where start off with the first die is 1, 4 bigger is 5. If the first die is 2, 4 bigger is 6. And then you can't go any more than that, because if the first die is 3, second die would have to be 7, but that's not a roll that actually happens for us with our 6-sided die. Okay, so again, that's 2 out of 36. And we're so close. Stay with me. We're so close, you guys. All right. F of 5, that's the probability that x is equal to 5. So let's think about, this means that the first die is 5 bigger, and let's start top down. We've been going from 1 and up, but let's start, if the first die is 6, that's 5 bigger than 1, and that's going to be it, because if we go down to first die is 5, well, that's 5 bigger than 0, which is not something that we can do. So this is 1 out of 36. And if we do -5, it's going to be the other way around, right? If we start with first die is 1, 5 bigger than that is 6. And if we try to keep going, well, 5 bigger than 2 is 7, but that's not one that we can do. Okay. So that was all of the possibilities. And then let's go ahead and just add in here f of q is equal to 0 if q is not 0, -1, 1, 2, -2, 3, -3, 4, -4, 5, or -5. There's definitely a shorter way I could have written that, but oh well. All right. And let's just go back and check something. So that's our probability mass function all written out, okay? For some examples, it's going to be a lot longer than others. On the dice example, it was really short to write out the probability mass function. On this one, it was pretty long. Okay, but let's double check something. So all of the outcomes should be taken into account here. So let's just note, right, when we add up these probabilities, we should get 1. So 6, 5, 5, and 4. Okay. So let's write that down somewhere. Okay, we had 6, 5, 5, and 4. And then we had 4, 3, and 3. Okay. And then we had 2, 2, and 1. Okay, and let's add those up. So that's 10, that's 10. 7 and 3 is 10, and that's 5, so that's a total of 35, but I think what happened, yeah, we get 1 out of 36 twice, so there's really another 1 here, and that total is all 36 outcomes. Okay. So when we add up the probabilities of the probability mass function, that should cover the whole sample space, which is an outcome of 1. All right, that is it for probability mass functions.